Hi, this video is for section 12.2 for Math 2. We're looking specifically at how to find the domain and the range of quadratic functions. So to begin with, let's go over the definition of what a domain and range are. So as you can see, the domain is the set of all of the x values, the inputs of a function. And so let's think of it as what you can plug into a function. And it also, when you look at it graphically, you can see that the graph is going everywhere along the x-axis. Okay, so even though it doesn't look like on your graph that this parabola is going to keep going to, say, 1,000,000 on the x-axis, you could, if you zoomed out for a really long time, find that point. You could also plug in 1,000,000 for x. It would be a very, 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 very either positive or negative large number. In this case, I think it's going to be really, 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 really negative. So it doesn't mean that it doesn't exist just because you can't see it. Just keep that in mind. So the domain is anything. You can plug in anything. You can plug in as long as it's a real number. You can plug in 1,000,000, you can plug in 1,000,000.2, you can do fractions, whatever. Okay? So the domain for quadratic functions is conveniently always going to be all real numbers. In fact, that is true of any polynomial function. And so since a quadratic function is a kind of polynomial function, it is always all real numbers. Okay, so that's it. Nothing's going to ever change with the domain for quadratic functions. All right, now the range is a little trickier. So the range is the set of the y values, and the y values are also known as the output. So after you plug in these x's, what kind of numbers are you going to get out? And those are going to be limited. And it's really going to depend on where the vertex is and if the parabola opens up or down. So that's going to be the focus here. So in this example right here, number 1, this is the equation in standard form. The vertex is right here. The highest point is at 3. That is the maximum. So the maximum is at 3. Okay, we can see that that's the highest level. It's almost like there's a wall there. And so your range is never going to go beyond that. Okay, your graph is going to stay 3, and it's going to keep going down and down and down and down and down. And so when we're writing the range, first of all, to write the domain, we put a capital D, or sometimes we don't have, it just says what's the domain. You could say all real numbers. You can also use this symbol, which is like a R with an extra line through it. That is a symbol that means the set of all real numbers. The range, just a regular R, so it's y's, and it's every y less than or equal to 3. It is equal to because it does hit 3, but it's never going to go above it. That's it. So that's your range. Okay, so I'm not going to write the domain for all of these because it's always all real numbers, but let's just focus on finding the range for all of these. So go ahead and pause the video and go and see if you can find the range for 2, 3, and 4. Okay, so let's take a look at each of these. So number 2, domain's all real numbers. The range is going to, well, we can see that it begins at -3. This point right here, the vertex, is a minimum. It's the minimum point. It's the lowest point on the graph. So there's a minimum at -3. And so this time, since the graph is going above, it's opening up, we say y is greater than or equal to -3. That is your range. Number 3, domain all real numbers. The range is starting at 2 and going down. So y is less than or equal to 2. Again, this is a maximum at 2. And number 4, we're starting kind of at the x-axis, but you got to think of that as 0. So it's the range is going to be y is greater than or equal to 0. And again, your domain is all real numbers. And there we go.